Read the question carefully. Here we got two processes. In the first process, we have 1000 gallon holding tank that has 800 gallons of water initially, and it's got 20 ounces of pollution. So if we let QT be the amount of pollution at any time t in the tank, then initial Q at 0 is 20. So initially it's got 20, okay, 20 ounces. Polluted water flows into the tank at the rate of 3 gallons. So here's the rate, 3 gallons per hour, and contains 5 ounces per gallon. That's the concentration. Concentration is 5 ounces per gallon. So rate 3 and concentration 5. Then well mixed solution lifts the tank at 3 gallon per hour as well. Same rate, getting out at the same rate, 3 and getting out same rate. Then we can determine the concentration of outgoing liquid. That will be always amount of salt at any time t, that's Q, unknown, divided by volume of the water. Here the volume of the water is not changing, okay, because getting in 3, getting out 3 as well, so 800 remains constant. Okay, that's the case. 3 gallons as well. When the amount of pollution in the holding tank reaches 500 ounces, so the moment when the amount of the holding tank, this tank reaches 500 ounces, so we begin with 20 ounces. When it gets 500 ounces, the inflow of the polluted water is cut off. So we get second process, okay. Then we have the second phase going on. What happens is then the polluted water is cut off and fresh water will enter the tank. Fresh water means concentration 0 here. Concentration 0 at a decreased rate of 2 gallon per hour. So it's now the rate is 2 gallon per hour. It was 3 initially, now it's 2. Pure water means, fresh water means concentration 0 at the rate of 2 gallons per hour. Okay, when the pollution in this tank reaches 500 ounces, so we need to find the time when the tank gets 500 ounces of pollution, then this second process starts. And in the second process, the rate is 2, concentration is 0. And let's read the question. While the outflow is increased to 4 gallon per hour, so getting out is 4 gallons per hour. Now we can find the concentration. Concentration will be always amount of salt, that's Q, over volume. So it's got 800 initially, but in this case the water level is decreasing. It's kind of draining because getting in at 2, getting out at 4. That means this tank is losing 2 gallons per hour. So 800, that's the initial, minus, because they're losing 2T. That's the volume of this tank at any time, the volume of this water. So 800 minus 2T. We got all the information for the second process as well. And if we read this, determine the amount of pollution in the tank after 400 hours of this process. That means it's the same thing, same tank, so 400 hours. So we don't know how long it takes to get 500 ounces. So 500 ounces. Yeah. So we need to find the time when the pollution becomes 500 ounces. Then the second process starts. So eventually we are asked to find Q of 400 equals what? What is amount of pollution after 400 hours? But for the second part, we can reset the clock. Okay, reset the clock. So, and we start with 0. That means it might take, I don't know, maybe 35 hours. Okay, it's 35 hours. Then that remains 365 hours. So we'll determine this in the context. So for the second process, the amount of salt, amount of pollution at the beginning. So I'm resetting the clock, so I'm start 0 again. That is when this gets 500 ounces. So 500. So let's write the differential equation plus initial value for the first one. So that will be then always dq over dt equals rate in, flow rate, we multiply 3 times 5, 15, minus we multiply this to 3 times q over 800, and we have q0 equals 20. Okay, this is separable as well as linear, but I'm gonna make it linear. Bring this to the left side. D cube over dt plus 3 over 800 q equals 15. So this is linear in q with respect to t. So we can find integrating factor. Integrating factor mu as a function of t is e raised to this 3 over 800 dt, and when we integrate this we get e raised to 3 over 800 t. Now we multiply this ODE, this linear ODE, by this integrating factor, then we get the left hand side is derivative of the dependent variable times integrating factor. Let me write mu for now, equals, we multiply right hand side by this integrating factor, so 15 times e raised to 3 over 800 t. I'm writing mu just to save space. Now integrate both sides, we get mu q times mu, which is this exponential function, equals, you integrate this, so 15, so exponential function when we integrate still same thing, 3 over 800 t divided by this factor 3 over 800 plus c. Okay, now we divide both sides by mu. Mu is in fact this exponential function whatever we have here, so divide by mu, then that's like q is a function of t. Okay, when we divide by this integrating factor mu, this is cancel, so this 800 goes on the top, and 3 divides 15 5, 800 times 5, so 4000, and when we are dividing by this is cancel, plus c divided by this exponential function, so c e raised to negative 3 over 800 t. Now we need to determine constant. If we go back, the initial amount of pollution is 20, so using that, using q0 equals 20, so this is 20 when t is 0, 4000 plus c e raised to 0, which is 1, so e raised to 0 is 1, we don't have to even write this. Okay, subtract 4000 from both sides, we get c equals 20 minus 4000, so 3980 negative. So now put this back here, thus the amount of pollution at any time t is given by 4000, c is negative 3980 times e raised to negative 3 over 800 t, and this formula is true as long as when this q is less than 500 ounces, because when the q becomes 500 then the second process starts. Okay, so this is true as long as we don't know the time, but when q is less than 400. Okay, now let's determine the time when the pollution reaches 400 ounces, then we can start the second process. Okay, sorry, 500 ounces, when the pollution reaches 500 ounces. Okay, so let's find the time. Find time t when q is 500. We just said q equals 500 and solve for t. That is now 500 equals 4000 minus 3980 e raised to negative 3 over 800 t. Now subtract 4000 from both sides, so negative 3500, and we have time, so divide by this, minus 3980, subtract 4000, then divide by this negative number, e raised to negative 3 over 800t. So negatives cancel, this cancel, take natural log both sides. So we have this negative 3 over 800t equals natural log of 350 over 398. Okay, then t equals, divide by this number, so this implies t equals whatever this decimal number is, natural log of 350 over 390, all divided by this negative 3 over 800, and using calculator we get, so we get 34.27 hours. So it takes 34.27 hours to have 500 ounces of pollution here. Now we have second process. In fact, second process starts after that 34.27, but I'm resetting the clock and again say 0. Now for the second process, now we need to do the same thing, the IVP, differential equation, and initial value. Initial value is here, so we need to write down differential equation, that will be d cube over dt equals multiply rate and concentration 2 times 0, just 0, minus 4 times this, so 4q over 800 minus 2t. Okay, this is separable as well as linear, so we can do separable or linear, doesn't matter. If we do linear, then you need to bring to the left side, but let me rewrite, this is dq over dt plus 4 over 800 minus 2t. I think it's so simple, let's make it separable, equals negative 4q. I'm just rewriting, pretty much rewriting, so okay, let me just separate the variables here. So this q bring to the left side, 1 over q dq equals, move this dt over, negative 4 over 800 minus 2t dt. Integrate both sides, so ln q, this q is a positive thing, okay, this is amount of pollution, so it's always positive. No need to put absolute value, is equal to, integrate this, and the derivative of bottom is negative 2. Derivative bottom is negative 2, but we have 4. How about negative 4? How about writing this as negative 2 times 2, because we had negative 4, I'm writing in this way, negative 2 times 2, negative 4. So pretty much I'm doing mini u sub. So 2 outside, the top is derivative of bottom, so entire derivative is natural log of 800 minus 2t. Again, time cannot go past this, so we don't have to use absolute value, plus c. Exponentiate both sides, so we get q equals e raised to the first 2 ln 800 minus 2t times e raised to c. We can say c1, and e raised to c1 is, we can write c, okay, and this 2, by the way, goes here in the exponent of 800 minus 2t, so that e and natural log cancel, so q equals, this goes there, so e raised to c1 we can just write c, and e, and this is just 800 minus 2t, okay, raised to 2. Now this is q as a function of t. Using the initial condition q0 equals 500, we need to figure out this constant c. Okay, using q0 equals 500, So Q is 500 when T is 0. So C 800 minus 0, just 800 square. I don't have to simplify. So C is 500 over 800 square. We can simplify, but we'll do that later. Plug back here. So Q as a function of T is 500 over 800 squared times 800 minus 2T squared. So this formula gives us the amount of pollution at any time T, and this is not valid forever because the tank is draining. It's getting, the fluid is getting in 2, is getting out 4, so it's draining by 2 gallons per hour. So it's got 800, so it lasts until 400 hours. Okay, just 400 hours, then it's gonna be, so in fact T is up to 400 for the second process. That's why we didn't have to write absolute value. Now we can answer the final question. So we were asked what is the amount of salt after 400 hours of this process, the total process, and the first process took 34.27. okay, then to get 400, so we just subtract 34.27 from 400 and we'll have some numbers we plug in there. Okay, note that for the second process was not at 0, we just reset the clock. So 400 minus 34.27 is equal to some number, and we just plug in there. So the final answer is, thus Q of this number is equal to, we plug in here 500 over 800 square times 800 minus 2 times T, whatever T is here, 2T square. Just use your calculator, that many pounds or ounces. This is ounces, I think. Go back to the question. So this is 360.73. Plug in here, and using calculator we get 3.67. Okay, pretty low pollution because the water is almost drained out. Because in 400 hours the water would be out, so 365.73 hours. That's the final answer.